Hi, everyone. Welcome to the well intervention course. Most probably, this will be the last session. This is number 9, session number 9. Last session, we start talking about cold tubing. And for the next hour, we will talk again about cold tubing, nothing but cold tubing. If you have any question, just raise it, and I will, from time to time, I will have a look. If you see any question, I will try to answer it. We ended up last session. We start talking about the factor affecting the pipe life, and I gave you a hint that what really affects the pipe life is the bending stress. Yes, we have some other items, but this comes number 1. Look first for what caused the bending stress. And in the presentation, in the slides you have, the biggest circle I made is the internal pressure wide cycling, because this circle, it combined 2 main killers: the internal pressure and the bending stress. We talk about spooling, it's a bending stress. We talk about real radius, which is a bending stress. We talk about the gooseneck radius, which is a bending stress. We talk about the gooseneck rollers. Then we have these slides, still talk about pipe life. We talk about the rig alignment. We talk about corrosive fluids. We talk about axial stress. We talk about the traction pressure. I will just remind you of the traction pressure. This is your pipe that you are running in the hole. And then you have the injector, which hold and inject the pipe in the well and out of the well as well. So these chains which grip on the pipe like that, if this pressure you have on the pipe is too much, this reduces the pipeline. Even if it is less than the required, it will damage it. Yani if it is too much or too less, both will affect the pipe, because if it is too much, this will cause fatigue to the pipe with the extra stress, extra force you have on the pipe. And if it is less, what will happen is pipe will start slipping due to its weight inside the well, or pipe will start to eject out of the well due to the pressure, the force pressure applying upward like that, pushing it out. So this will create a friction between the pipe and the gripper block of the chain that will cause damage to the pipe itself. So the traction pressure is an important factor. Storage and surface condition. Of course, there is a big difference in life, in pipe life, between someone who finished the job and he took his unit, put it in the yard, in the desert, or in the open air normally, exposed the pipe to the weather condition, to the water comes from rain, humidity from air, sun heat, from sandstorm, and someone else who protect his pipe against all these conditions by having just very simple, have a paint brush with heavy oil, like gear oil, for example, and paint all the surrounding of the pipe with this oil to make this very thin layer that protects the pipe outside diameter from surrounding. And someone who is more advanced, who care more about this pipe, he cover it with a tarpaulin to protect it. Of course, this affects the pipe life. Today, let us continue about the factor affecting the pipe life. One of them is the injector gripper block. What you see here in this picture is the chain. And these are the gripper blocks. This profile you see on the gripper block, it it represents the pipe of the. So this gripper block, for example, if it is designed to withstand or to hold 2-inch pipe, so this profile is to accommodate 2-inch. If you change the pipe size, you have to change your gripper block to match the new pipe size you have. So if an injector gripper block is not matching the size, so for example, you are using gripper block for 1.5 inch and you are using 2-inch cold tube pipe, you will damage your pipe, of course, it will collapse. Or even if it is the right size, but the gripper block is rusty, one of these teeth is broken, definitely this will affect your pipe life. The welding. The pipe, if for example, you got from the factory 15,000 feet of pipe, this 15,000 feet of pipe, it comes without any welding. All what you have is I wonder if you can see what's inside the pipe or not. But look at my finger here. You see a seam weld here. There is a seam weld here. I wonder if you can see it here. I think you can see it now. This is what we call a seam weld. This is longitudinal weld, because we don't, to manufacture 15,000 feet of pipe, in the past, last century, we used to get the strips from the factory. Then this strips, maybe it is 2,500 feet. Then we start making it a pipe. It passes through roller to make a pipe 2,500 feet. But then you have to weld, you need 15,000. So I have to weld another 2,500, another. Then each weld we do, this we call it butt weld. The butt weld is a very weak weld, because when you weld two pipes together like that, this weld, you make it as butt weld. This area between the two pipes, around the weld, you cause what we call heat affected zone. In this heat affected zone, all the cross-sectional area of the pipe is weakened. And it is true actually that in last century, when I was pulling out of the hole, when this butt weld come across the gooseneck, it breaks, because this is a weak point. It does not resist the bending stress, the cycle you are making, the pipe straight bend, it does not resist this. That's why, starting from the 80s of last century, we use another technique of manufacturing the pipe, which is strip bias weld. The strip bias weld, we don't weld pipes together, but we weld the strips together. So we keep welding the strips together till we have the total length required of the pipe. Then one time, this strip, it passes through a series of rollers where we can shape this strip into a pipe. Then we have this seam weld that you see it here, because there is no extra material you add, but you heat this area and you join them together. There is no filler material. This is the strip bias weld. But anyhow, without going into details, because this is not the course to talk about that, during the job, you might get a pinhole in the pipe. This pipe you are using, it has a pinhole. So this area is damaged. So when you go to the yard with your reel, you need to take this damaged part out. So you cut it, through it, then you weld it together again. When you weld the pipe together again, then you weld it using a butt weld, which is a weak point. And the pipe manufacturer tells you that if you do a butt weld, then you have to degrade my pipe. If the original pipe you purchased is its tensile strength is 100,000, then after you made this But well, it is not 100,000. Go to 90,000. So you degrade your pipe accordingly. If you degrade it with the tensile strength, then you degrade it with everything. All the mechanical properties is degraded. Number of cycles. Because the number of cycles you keep running hole, pull out, running hole, pull out, passing through the gooseneck. And the reel, when it is in the reel, it is bended, straight forward, straighten, you straighten it, then it goes to the gooseneck, you bend it again, then it goes to the injector, you straighten it. This cycle of straight bend, it affects the pipe life dramatically, yes. The overpull. Because the overpull means when you are running in the hole and you're stuck. To get free of the stuck, you need one of the way to get release from this stuck is to apply overpull. This overpull you applied is extra axial stress. This extra axial stress you created affects the tensile strength of the pipe. If the pipe tensile strength is affected, all the mechanical properties of the pipe is affected. Mechanical damage, which is the manufacturer defects, actually. As you see here, less than 10% failure are due to manufacturer problems. Then it comes something really, really dangerous, which is, I put it away, it is the ovality. When you buy a pipe from the manufacturer, this is part of a pipe, right? The factory gave you also with this pipe the technical data sheet. This technical data sheet you receive after you make the first running hole. Please don't treat it seriously. I mean the technical data sheet. Because forget it. It is not. Once the pipe is out, this pipe you received out of the hole, it is not the pipe you run it first time. Why? What I'm saying? The technical data sheet you received from the manufacturer based on the fact that the pipe you received is a pipe. It has one diameter. So if you measure any places, it will give you, if this is 1.5 inch, if you measure it anywhere, it is 1.5 inch. But after you make the first run, the pipe is not round. The pipe is oval. You won't see this by naked eye. There is a device that can measure that. But after the first run, the pipe have two diameters. It has D maximum and D minimum. And this creates what we call axial eccentricity. This axial eccentricity damage all facts that you have. It's a big story, not to talk about it today, but I need you to know that. All the mechanical properties you got for a pipe that comes out of the factory, it is based on one single fact. It is round. It has one diameter. But the time it has two diameters, the story is totally different. Without going into details here, yani, this is the pipe, this is round here. These are the grabber blocks that bite or that grab on the pipe. But look here, the ovality start to be clear here. I might go quickly here. When we are running in the hole, if the well is vertical, we have no problem. We have no problem. But if the well is highly deviated, or if we start getting into the horizontal section deep in the well, a lot of considerations has to be taken to tell us how deep we can go into the horizontal section. Otherwise, when you start going into horizontal section, now you are pushing the pipe in the horizontal section. It is not a weight now, the pipe or the injecting force, but you have to have extra force to push it into the horizontal section. If the pipe, if you have this force to push it, and if the pipe is not pushed, then you will start have this buckling. And this buckling might increase to a limit that you will be completely stopped. Again, without going into details, for this pipe to be pushed into the horizontal section, you need a lot of things to think about it and to calculate it. But when we talk about the pipe itself, I care about two main things actually. The OD and the thickness. Because the OD and thickness will give me the rigidity, which is what I need to push the pipe into the horizontal section. We discuss all this point that I escape into a course of 5 days. Each day is eight hours to talk about cold tubing only. That's why I cannot talk about this stuff here, yani, in 1 hour session. You see, this damage. This is due to external conditions. H2S, for example, يعني. H2S, if you work in H2S environment, that means that all your equipment should be H2S resistant. And I need you to know that if I tell you that this pipe is H2S resistance, do not ever think that if you submerge it in a bottle filled with H2S and you keep it there for a month, and you believe that when you come back, you will see the pipe. Of course not. It is H2S resistance for a limit. You should not exceed it. Otherwise, it will not. But this, again, this is a big subject not to talk about. See, this is the seam weld I told you about. When we weld the pipe, this longitudinal weld, the seam weld, this we call it the flash. This is external material that we need to remove it. The only way to remove it is with this type of pigs that we run it internally to remove this flash, because it is a weak point. You see, this is the buckling. This is the lockup. If you reach the buckling to that limit, you are locked. You will not be able to pull out back. I need you to know that the cold tubing we made, this is not made of one material. This is made of an alloy between 8 and maybe 12, 13 different materials. It depends on the application, and why we have it an alloy, because we need a different advantage that we cannot find it in one metal. So we take the advantage from that, and we take the advantage from the second one, from the third one. But of course, any advantage you take, you cannot take it alone. You take it with the disadvantage of that metal. That's why, for example, let us have the lower carbon content of a steel, the lower the strength of the pipe. But the low strength alloy are more resistant to H2S. So you remove the carbon content, you increase the resistance to H2S, but you alloy the strength. So it is a combination. You have to know what do you really need. The lower the sulfur content in the alloy, for example, the higher the resistance of H2S attack. But adding nickel to the alloy will increase the strength, but will reduce the alloy ductility and resistance to H2S. So you have an advantage, but again, you take it with disadvantage. So it is quite hard to make this combination that fits the job you need. I believe everyone of us know this relation, stress-strain relation. So I will just skip it. This is the power pack of the cold sealing unit. This is the source of energy, where we have the power. We have an engine. This engine gives us the power to run our unit, to run the injector, to run the BOB. Everything you have is run by this power you have, energy you have from the power pack. If I look at the other side of this power pack to see what the picture looks like in the other side, you will see here these cylinders. These cylinders, we call it accumulators. What's the accumulator? It is a steel cylinder like you see. What's inside it? Inside it, there is a rubber bladder on the top side, where we fill it with pressurized nitrogen at 1500 psi. The rest of the cylinder is hydraulic oil at 1500 psi. If during the job the power pack failed, now you are in a problem, right? Because you lost the power. Accordingly, you lost the control. So you might have a disaster, you might have a blowout. That's why we have this backup. If you lost the power pack, as long as it runs, it feeds this accumulator hydraulic oil, which is inside with 1500 psi. The moment the power pack failed, the pressure will drop. If the pressure drops, what happened to the nitrogen, which is 1500 psi, will expand. It's gas, because the nitrogen is 1500, but the hydraulic oil is less. So pressure will start going from higher to lower. So this bladder will expand, pushing the hydraulic oil in the desired hydraulic hoses required to give you pressure to be able to operate your pressure control equipment. So you can open and close your BOB to secure the well. You can increase the pressure to the injector to keep gripping on the pipe. Because if you are supplying these chains with 1000 psi, for example, if this pressure dropped, then this pipe might go into the well under its own weight, because its weight now will be greater than the pressure you apply. Or, as we said before, the well pressure might push this up, because the well pressure will be greater than the pressure of the chain at that time. So it is a storage energy. These accumulators are a storage energy to save your life in case of emergency, that if you lose the hydraulic power. As I said, this is This is a picture of the accumulator. This black is these are the ladders. Inside it is pressurized nitrogen gas that expands to fill the majority of the size of the accumulator, pushing the hydraulic oil to the required hoses. This is our injector that injects the pipe into the well and out of the well as well. These are the gooseneck. This is the gooseneck, and these are the rollers. What we have here is the hydraulic motors that run these injector chains. And below here, we attach our primary barrier, which is the stuffing box. Let us have a closer look with the injector. And let us remove all these extra steel and see what's remaining. This is what we'll see. These are the sprockets which is attached to the motors, hydraulic motors of the injector. These are the running sprocket or the drive sprocket. These sprocket below are just idle sprocket. This is just to complete the picture. And these dotted yellow strips are the injector chains, where the pipe goes inside it, between them, where we apply pressure. We apply pressures through these traction pressure. The traction pressure we apply through these piston and cylinders, which is attached to these skates, steel skates. So we push these skates to push the injector chain to grip on the pipe. This is the traction pressure, we call it. And if you look at the other side, these chains here, we cannot leave this distance, this long distance, uncontrolled. Otherwise, it will be loose. It might buckle. So what we have there is outside chain. We always keep 300 psi on these outside chain tension. So these chains are not buckled. So this pressure we apply to the outside chain tension has nothing to do with the pipe itself, but this is for the chain to avoid the buckling. Here our pipe, and let's start now running in the hole. We are running in the hole now. These chains are pushing the pipe down, controlled by, it's always grabbing on the pipe. If we need to pull out of the hole, all what we have to do is changing the circle. The inside becomes outside, the outside becomes inside, and now we are pulling out of the hole. Let us put everything back. This is our injector. And below here, I told you what's attached to the end, to the bottom, is the stuffing box, which is our primary valve. This is a cross-sectional area of the injector. We cut here to see what's there. This is the driver sprocket. This is the idle sprocket. These green are the skates, which is attached to these piston and cylinders, where we apply the traction pressure to grip on the pipe. And you see the pipe, the white pipe here. And this yellow sprocket, this is where we apply the chain tension, outside chain tension, to keep this chain, this distance from being buckled. Now we are running in the hole, and this is another picture of what we have here. These are piston and cylinder, where we control it from the control cabin. When we apply pressure this side, this is to grip on the pipe. We can apply pressure the opposite to make these skates away from. This is the gooseneck. And if you remember, we said when we increase the pipe size, we have to increase the gooseneck radius to minimize the bending stress. What you will see now, these are different sizes of gooseneck. The bigger side is for bigger diameter, the smaller size is for smaller diameter. This picture is taken while rigging up on location, where the supervisor used the crane to lift the injector, to move it all the way, to put it on top of the Christmas tree. This is our injector. This is our gooseneck. And this is our primary barrier, which is the stuffing box. These are the hydraulic hoses, which is connected to the control cabin, where I can control the movement of the injectors, whatever, I'm running in the hole, pulling out of the hole, I'm increasing the pressure on the skates, decreasing the pressure. If you look at this picture, if I am a company man or a company representative on location, and if I see this happening on my location, I will ask for the supervisor of this service company, and I will ask him to leave the location. Thank you very much. Leave the location. Take your unit and go home. What is the mistake I see in these pictures that makes me take this decision to ask the supervisor before he even start the job? I will tell him, go home, I don't need you. I'm looking for your answers, because since the beginning, none of you asked me a single question. So let me ask you this question. What is the fatal mistake in this picture that I see as a company representative, as the owner representative, and asked the supervisor of the service company to leave the location without even start the job? What's the mistake in this picture? I need some answers from you guys. I have how many? I have 29 participants. I'm looking for only 5 of you to answer. I will not dream that all of you, 29, to answer it, but I need just 5. I receive 1. The rig up of the hydraulic hoses. Okay. Any other answers? I won't say this is a good answer or not, because I do not to affect the others' answer. So I'm still looking for at least another 4 answers. Someone doesn't like it, so he left. I had 29, now I had 28, so he decided to leave. One answer say no stuffing box. So I have 2 answers now. Out of 28 participants, I have 2 answers. Shame on you. One more. We became 27 participants. So if I wait, I will have only 0 participants. So maybe I should not ask. Sorry for asking. I do apologize. Okay, we have a 3rd one. Sir, please repeat the question. Okay. I said, if I look at this picture, which represents a crane lifting the injector, moving it from the coil tubing unit, move it all the way to rig to rigged it up on the Christmas tree. There is a mistake in this picture. What is the mistake? So, Mr. Zaki, I repeated the question for you. I'm looking for an answer now, because we start having our number decrease. We became 26 participants. So if I'm waiting more, I will lose all my participants. Okay, the first answer which I have, the rig up of the hydraulic hose is a very correct answer. It's not just correct, it's a very correct answer. Yes. See, guys, now when the injectors are in the air, is in the air now, the weight of the hydraulic hoses plus the weight of the hydraulic oil inside these hydraulic hoses are loaded on what? On these connections. These hydraulic connections. You are damaging these connections. This weight of the hydraulic hoses should not be on the connections. The connection is not designed for that. So he has to have a safety belt, and then he connected to lift it on, to put it on the body of the injector. So now the weight is on the body, not on the connections. So this picture is bad because of that. Okay, let's continue. This is the stuffing box. If you look what's written here in white, SD Parker 4.06. This means this is a side door Parker, a side door stuffing box, side door element. And 406, this is the size of this stuffing box for 1/16 of an inch. And we call it side door because of this door on the side, where inside it is the element, the rubber element, this rubber element that seal around the pipe. And you see this profile is to match the pipe size. So fits. Two pieces, when you apply pressure, they grip together to seal around the pipe. This is the stripper rubber element. This is the stripper rubber element. This is actual stripper rubber element, and this is actual pipe. Huh? So if you need to change, during the job, if you need to change this element because it is damaged, you can easily do that by opening this door, this side door, open the door, and then you take the bad element out, put the new element, close the door, close the lock, apply pressure. In 5 minutes, you change the rubber element. This is our primary barrier. It works by pressure. These are made of polymers. It is self-lubricating, so you don't have to apply any grease or oil while running in the hole or plugging the hole, because these are self-lubricant. This is how it looks like. You show it in reality anyhow. We have 3 types of these stripper rubber, but we'll not go through them in this course, because all I need you to know that any type of them, the main function is to make a seal around the pipe. This is the pipe. This is the rubber element that seal around the pipe. If we apply, this is how it looks like. So it prevents the pressure that comes from the well. This will prevent it. From time to time, of course, it leaks. because there is a friction between the pipe and the polymers. So it leaks. But then from the control cabin, you can apply pressure to seal again. I have seen people in the field during the job, if the stripper, these polymers leaks, he increased the pressure. But the way he increased the pressure is really funny. People don't realize that all what you need is to apply 10 psi, 15 psi. This is sufficient to make the seal again. But people just, so whatever he gets 100 or 500, he doesn't care. This is really bad because the extra pressure you apply, it's an extra friction between this polymer and seal. So you are damaging your sealing surface rapidly. The size of this stripper depends on the bore. We have different sizes. Dressed for a specific size of coil tubing, of course. It is hydraulic. It works by hydraulic. And we have 5,000, 10,000, 15,000 psi, depending on your requirement. Some of them are H2S resistant. This is a specific requirement you have to mention because this is extra money. Do you see the picture in this slides below here? You see these components? These components are this. After the job, it was like that. Why? Bad selection of the polymers you are using. Now, we have different material. Normally, people, when they go to the job, they just grab this from the store and go. Normally, what we have in the store is the cheapest one. Yani, if you're looking for a cane of sugar, then you go to the supermarkets. Many people select the cheapest, as long as it is the same size and it looks white. So you select it. If you have one pack with $1, one pack with $0.75, of course, you will go for the $0.75. But you made a bad decision because normally we go for the, if you look here, the first one, which is the urethane, this is the cheapest one. And it is long wear. So it resists, it has a high resistance and it lives longer. So normally you go for that. But if you are going for a job with H2S and you select the urethane, this is what you will end up with. Because the urethane is not H2S resistance. You should go for the Veton. Veton is H2S resistance, but it is more expensive. Of course, you have to pay money. But believe me, it is cheaper than the urethane if you consider the whole job. I cannot go to, I will skip these pictures because of the nature of this course. This is our control cabin. This is how it looks inside, from inside. This is what you're going to see. You have controls. You can control everything in the unit. You can control the power pack, your BOBs, your injectors, everything you can control it from these knobs here. I always prefer this type of control cabin or control house, because you see the whole view. So you can see all around you. We have some of these now. All the controls are on your seat. When you are sitting there, so everything on the side of the seats. Then we have our secondary barrier, which is the BOB, blowout preventer. This is our secondary barrier control, isolating the well pressure during emergency. It provides means of holding the cold tubing. It can hold the whole weight of the pipe. Different type of BOP we have, different sizes, different pressure rating, different ODEs. We have standard service, we have H2S service. I think I skipped something, just a minute. What we see in front of us here, we call it quad BOP. Quad BOP because it has 4 actuators. From top, the first one on top is the blind. This is the ram. This is the blind insert. Let us have it here. This is the ram, and this is what we have inside of the blind insert. So if we need to apply, pipe should not be in place in the BOP at all. And then if we apply the 2 actuators, it will go like that. So if I put it down because it's too heavy for me to hold it, these are the 2 inserts. When you apply pressure, you see it became locked. So it will prevent the well pressure escaping out. The second one is the shear. These are the shear blades. These are the shear blades. So when we apply, if we need to cut the pipe, when we apply pressure, it goes like that. It cuts the pipe. The third one is the slip ram. What you have, what you see now is the slip ram insert. See this teeth? This is the slip ram insert. So when you apply pressure, the 2 rams, the 2 actuators closed. So when it closed, it will be like that. What you see here is to fit the size of the pipe you are using. This is actually for 1 1/4 inch. So it will hold the weight of 1 1/4 inch. If you see these teeth, it is different than the teeth of the slips on the rig floor. If you are on a rig floor, if you go to the rig floor one day while running drill pipe or while running completion, you use these slips to hold the weight of the pipe. If you look at the slips, you will see the teeth of the slips. Let me see, I have questions. Someone who said, sorry for being late. Oh, Fatima, you always come in time. Yani. This is, you missed a lot. Anyhow. I'm looking for. I have a question. Say, could you explain how the sealing element is self-lubricant? People sometimes believe self-lubricant like this polymer. It has holes inside, so oil comes out. It is self-lubricant. The material, it is very smooth, very smooth. So the friction is minimized. And is the shear ram sharp like a knife? To answer this question, you see, it is sharp, yes. It is sharp. It will not cut my hand, It is not that sharp like a knife, but it is sharp. And this profile, by the way, this profile is the design. Yani, we didn't make this profile for fun. Let me show you something. This profile we make, so when we cut the pipe, this is the pipe, right? You see it? This is the pipe. When we cut it, this is how it looks like after cutting. We need this. We don't need that. When we cut the pipe, we block this. We need it this way so we can start pumping through. So this is where, and the old type we have, I was not planning to discuss this with you guys. I don't have it with me now. I need to show you the old type. The old type was a V shape. This design is not a V shape. This design, because we need, when we cut, we increase the cutting area. So by doing that, we increase the force. So when we have a V shape in the past, when we cut, we have 2 points only. By doing this type, we have 4 points to cut. So we increase the area. Accordingly, we increase the force based on the magic formula I like. What is force? It is pressure times area. When you increase the area, you increase the force applied. The last one is the pipe ram. This is the pipe ram, and this is the pipe, the inner insert. I will drag it here. I have 2 of them. So when I close, this is the second one. So when I close, it will seal around the pipe here. This is the pipe ram, which is the last one. I'm looking for the question, please. Please tell again why there are teeth in the slip ram. Teeth are required to hold this pipe. If there is no teeth, if there is no teeth here, so this will be very smooth. There is no friction, so there is no gripping. But by having this teeth will bite on the pipe and grip on it correctly. And before looking to the question, I was telling you that if you go to the rig floor to see the slips on the rig floor, which we normally use it while running completion, while running drill pipe to hold the weight of the pipe. If you look at these teeth, these slips, you will see the teeth of the slips on the rig floor are facing upward. It is facing upward, so it will resist the weight. But if you look at these teeth, it does not face upward or downward. It is straight. Yes, it is straight because this is the way we need it. In coiled tubing, we need, when we apply the slip ram will hold the pressure, will hold the pipe, preventing the weight of the pipe, and also it will withstand upward force coming from the well pressure, from pushing this pipe out. So the slips being normal teeth, it will hold two forces. The force coming from below, which is the well pressure, pushing up, and the force coming from the weight itself, try to push it down. I have a question. What topic did we start today, a lecture from? It is a coil tubing. Can you please go again with the blind ram insert? Sure, I can go again with the blind ram insert. All 4 rams apply on the same time? No, one by one. And thanks for answering for the question. All rams go one by one? No, you apply the ram you need. And we will go now explaining this point. But let me go to the other. Can you please again, blind ram insert? This is the blind ram insert. In case of emergency and you need to stop the well flow, what you do is apply pressure to the first actuator. So the blind ram will close. When it closes like that, if you look here, yes, it is rubber against rubber. So this will prevent the well pressure escaping out of the well. We will explain how we activate the BOB in a couple of minutes now. So a blind ram, which seals the entire well bore, a pipe ram, which seal the outside coil tubing. This is the blind ram insert. This is the blind ram. This is the ram itself. This is the insert, the blind insert. This is what you see here. This is the pipe ram insert. This is what seals around the pipe based on the specific diameter. This is the cutter blades that cuts the pipe. It does not seal, it cuts only. And these are the slips, the slip insert, where it bites on the pipe to hold the weight of the pipe. Here another picture of the slips, slip ram insert. In case of emergency, and we need to secure the well, our primary barrier failed, and we have a major incident that we need to cut the pipe and secure the well. We will do 4 steps. Step number 1 is to close the slip ram. These are the slip ram. Here is the pipe. This is the pipe inside the well. So we'll apply the slip ram, then the pipe ram. So first thing is to close the slip ram, which is number 3 here. Then close the pipe ram, which is the last one. So now the pipe are in hand. And the pipe, when you apply a pipe ram, we secured the seal. 2 steps now we made. The third one is to cut using the shear blade. When we cut, then we pull out 1 feet. Why after cutting we have to pull out 1 feet? Because if we apply the blind ram, what's in front of us? It is the pipe. So it will not seal because this blind ram, it seals when there is insert to insert ram. Yani, if there is pipe, there is no seal. So the third step we did is to use the shear to cut. The 4th step is to pull out 1 feet. The 5th step is to close the blind ram. So the blind ram will seal the well, and you still have the pipe in hand. You don't have to fish it. These are the 5 steps. Close the slips, close the pipe, cut the pipe, pull out 1 feet, close the blind. Here are the 5 steps in sequence. Does anyone of you guys know what are the common sizes we have of the pipe? Is it 1 inch? Is it 2 inches? Is it 6 inch? Is it 18 inch? What is the common OD of the pipe we are using? Of course, we have different sizes. Do you know the average size? A question I have, will I be correct to say we only activate the blind ram when coil is out of the well? Of course, you cannot activate it while pipe are in. The only way to use it is when the pipe is out. Yes. Pressure should be equalized for closing ram, and what happened if shear ram failed? Pressure should be equalized for closing ram? No, you should equalize when you open the ram, because when you close, pressure above and below it is the same still. But when you close and you bleed off the pressure to work on whatever device you have, to open it now, you cannot, because pressure above it is 0, pressure below it is 3,000. So you have to equalize when you open, not when you close. What's the common size? People said 1/4. Another answer I received, I think smaller than 4 inch. Zaki said no, sir, but I don't know, no for what. No for not what, yeah, Zaki. Type. Okay, let's start with the sizes we have. We have 1/2 inch, we have 3/4, then we have 1 inch, then we have 1 1/4, then we got 1 1/2 inch, then we have 1 3/4, then we have 2 inch size, OD, then we have 2 3/8, and we have 2 7/8, and we have 3 1/2 inch, and we have 4 1/2 inch, and we have 6 1/2 inch. These sizes, starting from 3 1/2 actually onward, we use it for another application. We can use it called tubing for as a pipeline, especially underwater pipeline, because it is much faster, easier, cheaper. And we use it for completion. In Oman, Shell Oman, PDO Oman, Petroleum Development Oman, the owner, the oil producer in Oman. It was the first company in the Middle East to run coiled tubing as a completion string. That was back in 1993. We use a coiled tubing as a completion. We call it monobore completion. And we use these big sizes also for drilling, because we have coiled tubing drilling ring. We can drill a well with coiled tubing now. That's why we have these big sizes, 3 1/2, 4 1/2, 6 1/2. We have different thickness as well. I have another 10 minutes to finish. Yani. Sorry, I know that I exceeded the 1 hour, but I still 10 and we finish. What we see in front of us now, it is not a quad BOB. This is what we call combi BOB. Combi stands for combination BOB, because the 4 actuators here are 2 only, but the 2 do the same function at the 4, because the first one on top is blind shear at the same time. The second one is slip pipe at the same time. That's why we call it, but all other components still exist, like equalizing valve, killing port in the middle to kill the well from. But this one is better than the quad actually, because it's shorter, so our rig up is shorter. Plus, it requires less procedures. In the quad, we have to do 5 steps. Close the slips, close the pipe, cut, pull out 1 feet, close the blind, 5 steps. Here it is 2 steps only. First one, you close the pipe slips together. The second step, close shear and blind, shear and seal at the same time. So you minimize the steps. Our tertiary barrier in coil tubing is not the Christmas tree. It is a shear seal BOB. We call it safety head. The shear seal BOB, it is the first thing we put on top of the Christmas tree. And this one has to be operated from the control cabin as usual, and from another separate control panel, you can put it away from the location up to 200 feet, as we discussed. So you can secure the well if there is an emergency or there is a situation, hazard situation, you cannot stay in the location, or you cannot enter even the location. This is the sequence of how to use shear seal at the same time, to cut the pipe and seal the well at the same time. So if you look at the design here, it's different. These are the cutting blades. So you apply pressure, cuts the pipe, and you continue your movement. So the pipe will be bent, the lower part will be bent to fill this space. And you continue, and now you seal against these 2 seals. So you cut and seal at the same time. الcoil tubing, always you have to run bottom hole assembly, the tools you are using. So it's very important to talk about these tools quickly. And this will be our last thing to talk about. But please remember that when we use coil tubing, our primary barrier is the stripper rubber, our secondary barrier is the BOB, our tertiary barrier is the shear seal. This is the common practice. When we come to the bottom hole assembly, we use first thing we attach to the pipe is the connector. The main reason for a connector is to have a thread. We need a device with a thread, so we can connect our tools with this thread. So this is the main reason for having a connector. This connector, whatever we have, what we call internal connector, external connector, different story, but at the end, we need a thread. So to connect with this thread, we have to put check valves. This, the reason of having check valve. These check valves are normally flapper type. This flapper type is to allow you to apply pressure from above. This flapper will be open. But if you release this pressure, the flapper will close automatically, saving your life in case of emergency. So this will prevent the well pressure entering your pipe and preventing you from having a blowout from the surface if you have a pinhole at the surface. So these check valves, that's why we put 2 check valves to have a backup. After these 2 check valves, we put a hydraulic disconnect. The reason for the hydraulic disconnect, that sometimes when you run with long bottom hole assembly, deep in the well, especially in high deviated wells, you might get stuck. How you get out of this stuck, you try, but if you fail, then there is a device, we call it hydraulic disconnect, where you can drop a ball inside the coil from the surface. And this ball dropped all the way in. When it reached the hydraulic disconnects, it sits on the seat, preventing the circulation. So by applying pressure now, you are building up the pressure. You build up the pressure. When you reach the desired pressure, you will break a shear pins here. So the hydraulic disconnects are 2 pieces. The lower piece remain with the stuck pipe, with the stuck bottom hole assembly, and the upper part are coming out of the hole. After the release, the hydraulic disconnect, you can put any other device that suits your job, but these are the main component. Normally, it is a connector, check valve 1, check valve 2, hydraulic disconnect. Then it depends on the type of operation. I have some questions. For offshore application, are the surface equipment like power pack and control cabin are rigged up on the rig floor? No. Even on shore, all the coiled tubing components are on ground. The only thing that we use the crane is to lift it to rig on the rig floor or the Christmas tree if it's a rigless operation is the pressure control equipment and the injector, but the rest of the equipment are on ground. And when we talk offshore, everything on the platform, or you can work from a jack-up rig. So everything on the jack-up rig, and you move just your injector and pressure control equipment on the Christmas tree platform. I have a question here. What if the shear ram fails? If the shear ram fail on the quad BOB you have, or the combi BOB, you have the tertiary barrier, which is shear seal BOB. So you can activate the shear seal BOB. This will shear your pipe and seal the well at the same time. The only difference is on the quad BOB, when you cut the pipe, you still grab the pipe with the slips, which is below it. But on the shear seal, when you cut the pipe will fall down in the well, so it will be required to fish it later on. But your question might be more complicated if in your rig up you don't have a shear seal BOB. Because in this case, if the pipe, if the pipe is not cut, you are in trouble. The only way you have to do now is kill the well. I think I answered now all of your questions. And unfortunately, Dr. Ahmed, I am done. I'm done quickly. I mean, I escaped many topics, but anyhow, this is not a coiled tubing course, of course, and this is not a real well intervention course that we talk. But I hope that I gave you a general idea about this topic.
Ahmed, thank you very much for your class. It was amazing 9 lectures. I will be waiting for the remaining of the quizzes. For sure, we will do a final exam for the students, and any student will get 60% or higher. We'll give him a certificate signed by you and by Petro for sure. And we'll be happy to have you again in future classes.